Welcome to Waidsum Academy. Today we'll be looking at angle of elevation and depression in trigonometry. Remember, we've looked at the various type or different types of trigonometry. We've looked at Pythagoras theorem. After we looked at Pythagoras theorem using a right angle triangle, we followed to SOHCAHTOA using the same right angle triangle. After that, we looked at some of the trigonometrical ratio like the cosine rule and the sine rule we used to solve problems in trigonometry. And then after that, we looked at the application of trigonometry and we looked at the area of triangles in trigonometry. So today we're looking at the angle of elevations and depression, how we apply the trigonometrical formula to solve angle of elevation and depression problem. So without much ado, let's take a look at what we mean by this concept of angle of elevation and depression. First of all, what are the meaning of angle of elevation and depression? Angle of elevation is an angle that is formed when you're on the ground level. Excuse me. When you're on the ground level and you have an horizontal line, you have a horizontal base, and you raise your eye level to look at something upward, up the hill, maybe a bird on the tree. When you raise your eyes to your eye form, first of all, your eye level form a horizontal range. Okay, so when you raise them a bit from the horizontal range, you look up, an angle is formed between the horizontal level of the eye to a certain angle when you raise your eyes upward. So that angle is called angle of elevation. The angle that you have when you look upward to look at something on the top of a mountain, or when you look at something in the balcony and in a condominium. So these are called angle of elevation. But angle of depression is something, for example, if you look down from aeroplane, when you're by the window side in the aeroplane and you look down to look at the cloud or to see the sky or to see whatever it is, and then this is angle of depression. Or when you're on top of a mango tree, you climb a mango tree and you pluck a mango and you look down to see how many of the mangoes you've dropped down, and this is angle of depression. Angle of depression is the eyesight level, the horizontal level, the angle you make when you look down from the top. So this is called angle of depression. So elevation and depression are vice versa, and they're used very critically. Now let's take a look at this diagram. Here we'll be able to look at the concept of elevation. Elevation is to look upward. Okay, the angle you form when you raise this your eye level. This is the horizontal line for your elevation. Okay, so when you look at a bird in the sky, you're just by the seaside. You're by the seaside, and then just there you sighted an aeroplane or a bird flying in the sky. So when you raise your eye level, an angle is formed from the horizontal eye level. Okay, an angle is formed. That angle is called the elevation, angle of elevation. Okay, now imagine after a while you look downwards to look at the sea. Okay, to see the ship that is sailing on the sea. So the angle you make at that point is called angle of depression. Angle of depression. So anytime you look downward, the angle you make is called the angle of depression. And when you look upward, the angle you make is called angle of elevation. So this can be solved. Problems like this can be solved by using trigonometry, by using trigonometrical ratio, or by using SOHCAHTOA. So this kind of problem of elevation and depression are easily solved using a SOHCAHTOA method. Now let's take a look at this problem. Okay, we say a cliff is perpendicular to the sea, it's perpendicular to a sea. Okay, let's say the cliff is here, somewhere here, this FT or FM, whatever it is, and let's say the sea is here. A cliff is perpendicular to the sea, and the top of the cliff stands 24 meters. The top of the sea stands 24 meters above the level of the sea. See, the top of the cliff, this is the top. This is a cliff. This whole thing is a cliff. The height of the cliff is 24 meters above the sea level. So here, below here is the sea. Okay? So it's standing 24 meters above the sea level. The angle of depression, meaning you're on top of the cliff, you're looking downward. This is your eye level, the horizontal eye level, okay? Now you're looking downward, so you have an angle of depression here between the horizontal eye level and the line of sight when you're looking downwards. When you're looking at the sea at B, looking at the sea at B. So the angle of depression from the cliff to the boat is 35 degree. It's 35 degree. So remember, this angle is alternate to this place. It's alternate to this place, this whole place. Here to here is only 18. But the whole thing is what? The whole thing is 35. So you can say 35 minus 18, you get what is here, 17, right? So this remaining small place will be 17. Because the whole of this angle of depression is alternate to angle of elevation. So the whole of this place is 35. The whole of this angle B is 35 degree. Okay, now let's move on. He said at a point X meter up, the cliff is a flag marker and the angle of elevation from the boat to the flag marker is 18 degree. So at a certain point up, there is a mark on the cliff and the angle of elevation is 18 degree. Okay, this point we don't know, it's X meter. So we're probably going to find this. Okay, it's X meter, we're probably going to find this. Okay, now it said draw and label a diagram to show the top of the cliff. Always the cliff is a height, it's a vertical height. Okay, draw and label from the top of the cliff, okay, T, and the foot of the cliff F. So you put top here, you put T, and the foot you put F. And then the flag marker M. Flag marker is somewhere on the cliff, okay, M. And the boat B, labeling all the angles and distances given above. So we've been given angle of depression 35, and we've been given a small angle of elevation 80 degree, which is angle of elevation. I think the first question is for us to be able to draw this diagram only. Okay, that's the first question. So since we're told we're given these characteristics, since we're given all these characteristics, this is what we have. This is what we have. We'll be given okay, don't mind our line, okay? So here, let's make it a bit bolder. Okay, so we have this. I have this. Remember, from the top of the cliff, which is T, and the bottom here is F. There is an angle of elevation, so there will be a line of sight. So let's change the color here. Let's change the color here, okay. Let's change the color. There's a line of sight which will help you to depict your angle of depression. So angle of depression is here, 35 degree. Based on the questions or based on the information that we are giving the question. So the angle of depression is always the angle you have. This is the top of the cliff, T. This T, letter T. Capital letter T. This is the top of the cliff. And this is the bottom of the cliff, the pool foot. And the boat is somewhere away here at B. Okay, there is a marker here, a flag marker. So from here to the flag marker, there is an angle of elevation of 80 degrees. So we can show that with a different color. From here to the flag marker, we have an angle of elevation of 80 degrees. So here we have 18 degrees. We have 18 degrees. We have 18 degrees. So, but like I said, here they say we should note this distance. So from here downwards is X meter, because we don't know the distance. From the foot to the flag marker is X meter. Is X meter. from the foot of the cliff to the flag marker is 8 meters. But the whole cliff has been given to us, the height of the cliff has been given to us to be 24 meters. The height of the cliff has been given to us to be 24 meters. The whole height of the cliff has been given to us to be 24 meters. Okay. Now, this is the first question they ask you to draw. They say draw. We put degree here, put small degree. 80 degree, 35 degree. Okay, so the first question is A, draw the information. That's the first question. Question 1A. Draw the information that has been given to you. Okay, so this is the so far information. Remember, like I said, remember that we have the whole angle of depression equivalent to this angle of elevation. Even though they've not asked us for this, the whole of this is 35. It's going to be 35 degrees. Because angle of depression will be equivalent to angle of elevation. Angle of depression will be equivalent to angle of elevation. Okay, maybe we might need it, especially if we want to use the trigonometrical function. Maybe they might ask you to find from the distance of the cliff to the boat, where the boat is, this one. So that will be opposite over adjacent. It will be tan 35, will be opposite over adjacent, if you want to find here. If you want to find the longest side, which is the hypotenuse, then you will be the longest side, which is the hypotenuse, from the boat to the top of the cliff. If they say from the boat to the top of the cliff, then we will look at the opposite over hypotenuse, which is sine 35. It will be sine 35. But however, let's take a look at what the question wants us to do. The B part of the question, find the distance from the boat to the foot of the cliff, meaning this one, from the boat to the foot of the cliff. The distance from the boat to the foot of the cliff. This distance. Because the boat is B. To the foot of the cliff, we want to find this. So like I said, the whole of this place is 35 degrees. The whole. Because it's alternate to this place. Alternate angles are equal. Okay? Alternate angles are equal. So the whole of this place, okay, if you look at it from the second case, the whole of this place is 35 degrees. Why? Because it's alternate to the depression. Angle of depression is always equal to angle of elevation. So the whole of this place is 35. The whole of this place, all, is 35 degrees. And we already have 24. So we are looking for the foot, this distance. So it's opposite. If you're using the SOHCAHTOA, it's opposite over, because you'll be given the opposite side, and you're looking for the adjacent side. So opposite over adjacent is what? TOA. So we're going to use the TOA concept. We're going to use the TOA concept. Let's say, so in this case, we're going to use it because we've been given, we know here 35, we know here 24 meters, and we're looking for here. I can call it Y. This is the distance we're looking for. So opposite over adjacent is TOA. If you look at the SOHCAHTOA, which of them we're going to use? We're going to use the TOA. We're going to use the TOA and SOHCAHTOA. So if you're not sure, you can write it down, write everything down to test which one you're going to use. Because when we're doing elevation and depression, we'll be applying the SOHCAHTOA that we've learned before. We'll be applying the SOHCAHTOA. Now when you see here, TOA, the TOA part is opposite over adjacent. So when you have opposite over adjacent, then we're going to use TOA. So you say, TOA means tan. So you say tan 35, the angle is 35. So you say tan 35 is equal to the opposite, which is 24 degree, and sorry, 24 meter, the height. 24 over the side you're looking for, 24 over y. So tan 35 is 24 divided by y. Okay, remember where we said if you have, you can use the blue triangle formula to solve this. Or you say just cross multiply. If you don't know how to use the blue triangle formula, just say cross multiply. here what it means is tan. It means tan is equal to 24 over y. So if you're looking for y to be 24 divided by tan, so y will simply be 24. If you cross multiply, you still get the same thing. Because if you cross multiply, you get y tan 35 equals to 24. So y will be 24 divided by tan 35. So y will simply be 24 divided by tan 35. In this case, you can key everything to your calculator once if you know how to use, or you do the tan 35 at the bottom first before you do your final stage. But however, we can just key everything to our calculator and get the final answer. Is that okay? Okay, so our y will be what? Our y will be what? 24 over 35, you get 34.3, right? You get 34.3. So you pause at this point to one decimal place. Pause and key in your calculator. Pause this video and put these values in your calculator and see if you will get 24.3. If you get 24.3, 34.3, then you're good to go. You're good to go. Okay, key this in your calculator and see if you get 34.3 meter. Remember it's distance. Okay, remember is the horizontal distance from the foot of the boat to from the foot of the cliff to where the boat is. Okay, so remember it's horizontal distance, so it's in meter. It's in meter. So that's the first part of the second part of the question. Let's see if we have third part. If there's C, yes, C. Find the value of x. The C part is to find this from the foot of the cliff to the flag marker. Find the value of x. So here we're also going to use a trigonometrical relation. We can bring out the small triangle. Okay, we can bring out the small triangle by simply say consider triangle, this triangle FMB. FMB. If you consider triangle FMB, you also have a right angle triangle. So opposite over adjacent. You remember we already found this. Opposite over adjacent is also still tan 18. Tan 18 will be x divided by the one we just got, 34.3. So tan 18, which let's key in C. The C part of the question says you should find x, because it was part of the question. X is the distance from the foot of the cliff to the flag marker. Find x. Okay, now let's show it again from here so you see it. Find this x. To find x, remember we found y already. Y is 34.3 meter. We found y already, 34.3 meter. Now they want us to find x. They want us to find x. To find x is to bring this out as a triangle on its own. F, M, remember here was M. So FMB is a small triangle on its own. So we can bring it out. Let's bring the triangle out so that it's easy for us to consolidate x that we're looking for. Here is the x they asked us to find. This F, the foot of the cliff. This is M, the flag marker. And this is B, the boat, where the boat is. So this angle was 80 degrees. 80 degrees. Okay, now we are asked to find this. Remember, we already calculated this place to be what? We already calculated this place, this BF, which we called Y. We already calculated it to be we already calculated this place to be 34.3, right? We already calculated this place to be, sorry, I'm having the internet restoration problem. Okay, so here we already calculated 30 to be 34.3. So what we do is just to find this one, which is opposite to this angle is x. X meter is opposite to the angle. So opposite over adjacent, because we already know here. They didn't give us here. So since they didn't give us here, we're not using here. It's opposite over adjacent. So it's also tan 18. Okay, I'm still having connection problem. Just a minute. Okay, let's continue from here. If our Yungu Shugo is not showing itself. Now we consider the triangle FMB. Look at it. Here's the B. Here's the M. Here's F. And it's angle 90. This is the X meter. And this is, remember we solved this one. No need to write 24 over tan 35. We've already obtained the value. And the value is what? The value is 34.3. So you say opposite over adjacent, tan 18, is equal to opposite, which is X, over adjacent, which is 34.3. Or you can write the whole value that gave that 34.3, but it's always better to write the value already. It makes it easier for you. Okay, so when you do that, you cross multiply, you make X the subject, then you will get X to be 11.136 meter in one significant figure. To three significant figure or to one decimal place, it becomes 11.1 only, 11.1 meter only. So that's the value of X. That's the value of X. Okay, our board is still laggy. So we just continue the explanation from here. Okay, so that's that for that. That's the how to use the elevation and depression. Most of the time, when you have the angle of depression, because if you look at the depression, it's actually out of your triangle. It's out of your triangle range. So how do we use it? You just say this value of the depression equal to the elevation. You equate it to the elevation. So the depression itself is out of your triangle, your right angle triangle. Because it's out of your right angle triangle, how to use it? You just say the angle of depression equal to angle of elevation, then it becomes, it falls inside your triangle. Now that it's inside your triangle, you use the SOHCAHTOA to find this whole distance that they asked us to find. After that, we also find this one that they asked us to find. So this is the application of trigonometry when they're considering angle of elevation and depression. So with this, we come to the first small part of the work.